By the end of this lesson, students will be able to set the measure of three angles within a triangle equal to 180, find the measure of an angle within a triangle when given the measure of the other two angles, and find the measure of angles within a triangle when given a number or algebraic expression for each angle. The triangle sum theorem states that the measures of the three interior angles in a triangle add up to be 180 degrees. Notice here at the bottom that we have a triangle in which the three angles are equal to x degrees, y degrees, and z degrees. So due to the triangle sum theorem, we know that they all add up to be 180. So x plus y plus z equals 180. Here's an example of the triangle sum theorem. We're asked to find the measure of angle T in triangle RST. We know that the sum of a triangle is equal to 180 due to the triangle sum theorem. So the measure of angle R plus the measure of angle S plus the measure of angle T is equal to 180. Since we're given values for the measure of angle R and the measure of angle S, we can substitute those values to find the measure of angle T. And again, all three angles add up to be 180 due to the triangle sum theorem. The rest becomes algebra. 54 plus 67 equals 121. We bring down the measure of angle T, which is all equal to 180 again. Now we subtract 121 from both sides. So the measure of angle T is equal to the measure of 180 minus 121. The measure of angle T is equal to 59 degrees. Here's another example of the triangle sum theorem. We're asked to find the value of each variable in triangle CED. We know that due to the definition of vertical angles, the angle BCA or ACB is equal to the measure of angle DCE or angle ECD. Therefore, x equals 85. Now to find the value of each variable in triangle CED, we know that x plus y plus 55 is equal to 180 due to the triangle sum theorem. We found that the value of angle x is equal to 85 due to the definition of vertical angles. So we're going to substitute 85 for x. We bring down the y, bring down the 55, and again the sum of a triangle is equal to 180. The rest becomes algebra. We combine like terms, so 85 plus 55 gives us y plus 140, which is equal to 180. We subtract 140 from both sides. (140 minus 140 is 0, so y equals 180 minus 140. 180 minus 140 is equal to 40, so y equals 40. So x equals 85 degrees, and y equals 40 degrees. Here's another example of the triangle sum theorem. We're asked to find the value of each variable. Starting from the right side, we see that this triangle is equal to 180 due to the triangle sum theorem, and we only have one variable to find. Therefore, 43 plus 57 plus y equals 180. The rest becomes algebra in order to find y. 43 plus 57 equals 100. Bring down the y. they're all equal to 180. Next, we subtract 100 from both sides. So y is equal to 80. Next, due to the definition of vertical angles, we know that y is also in the left triangle. And again, we found that y is equal to 80 degrees. So the sum of the left triangle is x plus x plus y, which is 80 degrees, is equal to 180. The rest becomes algebra in order to find the value of x. X plus x is 2x. We bring down the 80, and we set it equal to 180 again. So now we subtract 80 from both sides. 2x plus 80 minus 80 is equal to 2x. 180 minus 80 is equal to 100. The next step is to divide both sides by 2, since we're multiplying x by 2. So 2x divided by 2 is equal to 100 divided by 2. 2x divided by 2 is equal to x, and 100 divided by 2 equals 50. So x equals 50. So the final values of each variable is that y equals 80 and x equals 50. In our final example for the triangle sum theorem, we're asked to find the value for each variable. Notice that we have a triangle in which the measurements are 55, 28, and 1 is represented as an expression, which is an algebraic expression, which is 40 plus y. Therefore, 55 plus 40 plus y plus 28 is equal to 180. The rest becomes algebra in order to find the value of y. So 55 plus 40 plus 28 is equal to 123. We bring down the y, and we set it all equal to 180. Now we're going to subtract 123 from both sides. What you do to one side, you do to the other. So we're going to subtract 123 from both sides. We bring down the y. 180 minus 123 equals 57, so y equals 57. Next, we're going to use the definition of a linear pair to find the value of x. We're given the expression of 6x minus 7. So 6x minus 7 plus 55 equals 180. And again, this is due to the definition of a linear pair. 55 minus 7 equals 48. So 6x plus 48 is equal to 180. Next, we're going to subtract 48 from both sides of the equation. (6x) equals 180 minus 48. So 180 minus 48 equals 132. We're going to divide both sides by 6. So 6x divided by 6 is equal to 132 divided by 6. Therefore, x equals 22. So the values for the variables are that y equals 57 and x equals 22. Students should now be able to set the measure of 3 angles within a triangle equal to 180. Find the measure of an angle within a triangle when given the measure of the other 2 angles, and to find the measure of angles within a triangle when given a number or algebraic expression for each angle.